Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and you could say that when it rains it pours. So last week I made a video on optimizing 3D games in GameMaker using a new feature which was recently added in recent GameMaker betas, which will allow you to more easily reuse the transformation matrices. That yielded some pretty nice performance gains when rendering things such as this entire forest of tree objects. Anyway, today we are going to be talking about another trick that was added in recent GameMaker betas that you can use to speed up your 3D games in GameMaker quite nicely, except this one was actually not like hot off the presses. This was actually added to GameMaker like 6 months ago, and nobody knew because it was not in the release notes. And this was pretty much a complete secret until Patrick Crafe said something about it in the Discord a few days ago, and you can interpret that as you will, either as like a lovely surprise or maybe a little bit of a more pessimistic view of the state of GameMaker's release notes. Anyway, so we are going to be talking about Sphere is Visible, which is a way of doing much more efficient visibility culling or frustum culling than you would be able to do if you tried to just do it yourself in GameMaker using GML. So I am going to be drawing a scene that is much like what we were using last time with the matrix transforms. I've gotten rid of some of the stuff that we don't need. I've commented out like details about like the scale of the trees. We'll come back to that later because there's some things that you want to keep in mind with this. Anyway, crucially, we are drawing now 10,000 trees every frame, and we're not doing any work to see if they're like in front of the camera or not. This is something that you could do previously in GameMaker in GML on your own. There are like better and worse ways of doing that. I actually made an earlier video on optimizing 3D games in GameMaker that did talk about like approximations for frustum culling and that kind of thing. And it definitely can help, but maybe not as much as people would like. And also, like, if you do it wrong or if you do approximations like I was in that video, it's possible that you could find like weird holes in it where sometimes objects are called that shouldn't be or objects aren't called that should be. Anyway, starting in current betas and officially in like 2024.14 monthly is when this will be officially released. GameMaker will do that for you. By the way, I forget if I said earlier, but I have made quite a few videos on optimizing 3D games in GameMaker. If that is something that you're into, you might want to go and watch some of those. I'll put links on screen and stuff. So the function that we are looking at today is a fairly unassuming one, and that is going to be the function sphere is visible. And this is going to take 4 arguments, an x, y, z, and a radius, basic definition of a sphere. And it will return a true or false based on whether or not a sphere with that position in the world would be visible to whatever camera is currently active. So let's unpack this a little bit. So these tree objects here are very much like not like spherical, which means that to use this effectively, we are going to have to find a way to approximate each of these tree models or whatever other model you happen to be drawing as a sphere. And the easiest way to do that would be to, for each vertex in the tree model, I'm just going to pick on this one like where I'm standing. If you iterate over each vertex in the tree model, you find the point in the model that's farthest away from the origin, and you say, okay, that distance is just the radius of a sphere which circumscribes this tree model. That's a basic way of doing it. There are ways of finding a bounding sphere of a model which will be a little bit more precise and will waste less space, but for the purpose of this video, I think that's going to be good enough at least to start out with. Anyway, once you figure that out, you can say that that's going to be the radius of a bounding sphere for an object. To check if that bounding sphere is visible to the camera, we can take the position in the world where each tree is drawn. So we can say sphere is visible. The x, y, z is going to be, in my case, data.x, data.y, and a z coordinate of 0 because these guys are all just sitting on the floor. And the tree radius, or whatever the radius of the bounding sphere that we figured out is. So I'm going to get around to actually calculating that later in the video. For the time being, I'm just going to hard code this to be about 240 because that's what I worked it out to be about beforehand. And we're just going to assume this is correct. Later on in the video, I will like do that calculation for real. Anyway, so this is going to return a true or false based on whether or not a sphere at this position and of this radius is visible to the camera. And we can say if, well, we can do this 2 ways. So we can say like, if sphere is visible, then do all this. Or it might be a little bit... Some people at least prefer to look at things the other way and say, if not sphere is visible, then don't do anything, then just continue on to the next iteration of the loop. It doesn't matter, it amounts to the same thing. So if I were to now run this, we would be able to see that you can actually see that the number of trees that are drawn, like obviously you can't see things that are outside the view of the camera because they're outside the view of the camera. But if you look at the little debug ribbon at the top of the screen, we can actually see that in probably the average case, maybe a quarter of the total number of trees are actually being drawn. If I were to run all the way back to like the edge of the world and turn to face where we came from, obviously there would be more because now we have a majority of the trees being drawn like this, and we're pretty much about back to where we were when we started performance-wise. But if I were to look away, most of the trees are not going to be drawn, and performance dramatically improves. And I meant to, before I did anything, I meant to go and run this in the debugger's profiler so that we could actually... Oh, hello. Yes, let's click allow on that, and then let's not lose control over the camera. I meant to go look in the debugger's profiler so that we can see actually how much time is being taken up by doing different things. We can ignore the step percentage because that's not going to help us right now. We can sort by most expensive in terms of milliseconds, and we can just like expand these headings and see what in here is taking up the most time. So drawing 10,000 trees is taking up about 9 milliseconds on my computer. And you can subdivide that into doing things like the vertex submit and the matrix set and the matrix build and all that kind of thing. All right. A lot of the other stuff that's taking up time in here is also just like math and like generic stuff that the profiler doesn't really track. Anyway, I think that's enough of that. We've got a pretty good sense of how expensive this operation is. What if we didn't go and draw all 10,000 trees when not all these trees are visible? So exactly what kind... Oh, I've got to restart the game. Exactly what kind of savings we can expect here does depend on like actually how much of the scene is visible at a time. I am going to try to approximately put the camera where it was the first time and start profiling. So we can see that if I do this, it looks like maybe a third of the trees are visible, so 3,000-ish. And if I just stand here and profile the amount of time that it takes to go through all that, we can see that we now have all those trees, the whole world being drawn in about 4.5 milliseconds, which is almost exactly half of what it was before, a little bit less. And we are drawing a third of the trees. It's not going to be a completely linear relation because there are other things that happen in this code for drawing the world. Besides drawing trees, you're not skipping like all of it. You still have to do parts of the loop and parts of the other things that are out here. But all in all, by just like using the sphere as visible check to figure out what is visible to the camera at any given moment, we can, especially if you have a big world where at any given moment, a lot of stuff isn't visible to you, you can save a lot of time. And this is something that's really nice to have to just have access to in GameMaker without having to do it yourself. I just noticed that this distance to tree and the direction to the tree variables, these are being calculated but never used. And I'm wondering if I were to get rid of that, how much exactly faster would this be still? Like how much of that frame time chunk was like actually not being used for anything. So let's put the camera back there. Let's profile this once again. And we are down about another millisecond. All right. Definitely we'll take that. So calculating things that don't end up being used are definitely a potential source of slowdown in your game. Speaking of which, I did find out why in the last video like matrix set was more expensive than I expected it to be, and that was because the tree model was never frozen. The tree vertex buffer was never frozen, which meant that the model lived in main memory and had to be transmitted to the GPU every single time you drew it, which is less efficient than freezing it, copying the data to VRAM, and then just like leaving it there. It's another thing to just keep in mind. I'm going to stop profiling. I think we have made our point with, well, exactly what kind of an advantage you can see from this. And now I think I would like to move on and talk about actually figuring this out. So this isn't a difficult thing to calculate, and honestly, if you're this far into 3D and GameMaker, you can probably figure it out on your own. So I'm going to go and just make myself a little script. We can call this get vertex buffer radius or something like that. And this is going to be a function which will take a vertex buffer as a parameter. We will use it by saying something like tree radius equals get vertex buffer radius vb underscore tree. We are going to want to go and iterate over everything in the vertex buffer before we basically to get that information out of it. And we can't do that directly, unfortunately, so we are going to have to say var something like var data equals buffer create from vertex buffer, and that's going to take a couple of arguments. I believe it's the vertex buffer, the type, which can be buffer fixed, and the alignment, which can just be 1. This is going to take the vertex buffer that we created. We are going to buffer delete that when we're done. We're going to copy that vertex data into like a regular data buffer. We're going to delete it when we're done. And now we can just iterate over it. So you're going to have to be mindful of the vertex, like the size of the vertex format that you used when you created this. So in this project, and probably in most GameMaker projects, you're going to be working with like a 36-byte vertex format, which is going to be 12 bytes of 3D position, 12 bytes of vertex normal, 8 bytes of texture UV, and 4 bytes of color. That's a pretty standard 3D vertex buffer vertex format. If you're using some other vertex format, you might have to like adjust the code that I'm about to write. But instead, we can iterate over for var I equals 0. I is less than buffer get size data. And we're going to want to iterate over this not byte by byte like I++, but we're going to want to iterate over this vertex by vertex, which is going to be I plus equals 36, because we're going to be looking at 36 byte chunks. We can say var x equals, I'm going to say xx equals buffer peak. The data buffer at index I, the type is going to be buffer float 32, because in our bog standard 3D vertex format, the 3D position comes first, XYZ. Var YY equals buffer peak data index I plus 4, buffer F32. And ZZ is going to be I plus 8. So each of these values is a 32-bit float, 4 bytes. X is going to be the first one, Y is going to be the second one, Z is going to be the third one. We can also figure out the var distance equals point distance 3D, and we could use this to figure out the distance from the origin in like local model space to that X, Y, Z coordinate. We will also want to keep track of the greatest distance, like I said, so we can save our largest distance. We can initialize that to 0, and largest distance can be the max of the largest distance and the current one, so we can update the largest distance if the distance to the point that we just looked at is greater. And when we're done, we can return that. And that's going to be our radius, so to speak, of this model. So this is going to work as I've written it here. We should probably also go back and instead of making this tree radius a hard-coded local variable, we can do it properly like that. If you'd like to see what it is, we can just like show message that value right after we figure it out, and that will that'll tell us what it is. 215.14 apparently. And if I use that value in this code instead of the hard-coded value, we can see that it's going to work. We can see that we are drawing some variable amount of trees based on where we're looking and where we're standing. This will not work if you were to freeze the vertex buffer before doing this, because if you do freeze a vertex buffer, that does make it read-only, and among other things, that means that you can't like extract data from it and turn it back into a regular buffer. GameMaker will error if you did that, so don't do that. It will not work if you're going to extract like bounding box information or bounding sphere information from a model like this. Do that before you freeze it. Honestly, what you really want to do is you probably want to just like load this from a file so that you don't have to calculate it when the game starts, just because that's faster to do it that way. But the same could be said for these 3D models, which are currently just being parsed from a text-based model format, which is also not the swiftest. Let's see. I did mention that the scale of these models is something that we're going to have to take into account. So when I am drawing all these vertex buffers with a scale of 1, that means that the radius of the bounding sphere is just the radius that we calculated when we iterated over it. But if you were to scale up a model, so if you were to draw the model at like 2x, then you would also need to accordingly adjust that, like the radius of that bounding sphere. And initially, I had set the scale of these models to like a random number between 1 and 1.5. If I were to set this instead to like 3, and if I were to go and bring back the scale component of this transform, and if I were to run it like this without doing anything else to the tree radius, you would see that around the edges... Alright, well, one, they're a lot bigger. Can I make the camera farther away, actually? That would help being able to see. Camera distance, let's make that like 2,000 instead of 1,000. And if I were to move the camera around, you would be able to see in at least some places the trees are going to disappear at the edge of the camera. And if I were to make this even more extreme and give this a scale of like 5 or something like that, you would probably see it a little bit more like that. And that is because the sphere... So like when I walk forward like this and you see the models popping out of existence, the bounding sphere that we initially calculated for the radius of these things is like 200 or so, but when I scale them up like this, the tree is now actually like physically quite a lot bigger than that, at least as physically as you're going to get in computer graphics. Like in the way it's gonna come through on screen, in the way that the vertices are going to be transformed in the vertex shader, it's going to be a lot bigger than that. And this is one of those things that can cause a bit of an inconsistency in like where the game thinks the tree is when it does the sphere visibility check versus where it actually is when it ends up on screen. And if you wanted to get rid of that little problem, you would probably do something like multiply the tree radius by the tree's scale, like this. That is a matrix. That is a data.scale is the scale of the actual tree objects like this. And if I were to do this, we could see that everything would be back to normal. The trees are much, much bigger than they were before, and that's kind of its own thing. But we still have frustum culling behaving correctly when we correctly account for scale like this. This is not something you have to do for rotation because spheres kind of don't rotate. Like, that isn't a thing that makes sense to do. Other potential issues where this might come up are if you have like some sort of like skeletal animation that's computed in the vertex shader. You would have to then be careful that the bounding sphere's size is multiplied by the greatest extent of whatever bone is farthest away from the origin or something like that. Let's see, what else? Let's undo that because that looks weird. I'm going to go back to the random number between 1 and 1.5. I think that helps to make the forest look a little bit like, you know, maybe not almost exactly the same trees, but they still do look pretty similar. They are the same tree. Anyway, the last thing about this is that, like I said earlier, the tree model that I'm using here, that I could just open up, is going to... It's going to be centered on the... It's going to have, like, the base of this tree model centered on the world origin, and, like, most of the tree is going to be kind of high up in the air. And if I were to actually draw a circle around that for the bounding sphere, the way that I've calculated it here, we are going to have a bit of wasted space. This is not the most efficient bounding sphere that you could draw around this thing. There are other ways of doing this, for example, like taking the barycentric center of the tree model and calculating the furthest extent of each vertex from that instead of the origin. But then you would have to do a little bit of additional math to like transform the center of the bounding sphere, because then it wouldn't just be like the model's XYZ in world space. And I think that's quite enough to be getting on with right now. That can be like your homework or something. So, I'm going to end this off here. My name is Michael. I like Wizards and Dragons and making games. If you want the sample project link to where you can find it on GitHub can be found in the description of the video. That is not GitHub Desktop. That was Discord. Let's make this a commit. I don't think I spelled visibility correct there. Anyway, I like to make videos on weird stuff you can do in GameMaker, which sometimes includes 3D stuff like this, so if you're interested in this sort of thing, feel free to subscribe. You should all go check out Wizard X and the Lost Out, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to that Steam page can be found down below. I hope you all found this useful. Let me know what kind of speed up you got in your 3D games in GameMaker from this, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Pixelated Pope, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, and Bokeh Dev for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.